Okay, this part, let me get the pen. So this part here is what we talked about, which is the formula to calculate the pump GPM. And if you look in the bottom here, that part is where you fill in the blank. So on the top going to be the heat load for the loop, for the whole loop. And delta T is the temperature of the water coming in and the temperature coming out. So you plug in those in, you run the math, and you get your GPM. So this is going to be part one of this equation, because we said we need two things for the pump. First one is the head, and second one is the head. So the second part, which is finding the pump head. So this is the pump head, and if you notice here, LA is the length, and this is the pipe total length, and the fitting converted into length. That's going to be from the table. Each one will be a different length. And so we're gonna fill in the blank, which is first of all is the pipe length. This will go into this part here, which is basically the total pipe length in the loop. Total pipe length in the loop. What about these little things here? These are basically each fitting and the number of fittings. For example, if we have 90 elbows, we're going to put 90 times the conversion rate, which is like either 2, 3, 4, or whatever you have. So, and you're going to keep going. And here, I assume you have only 3 types of fitting. If you have more, you're going to add, and it's going to be the same thing, fitting times length, and so on. Doing that, again, you'll crunch the numbers. This number will transfer the way it is, and these numbers will become 1, and so on for here. So this is going to be here, and this will be here, and this will be here. Then you add them all together, and voila, you get the final total pipe length. So now to use, you're going to use your GPM, which you get from here, and you're going to find constant A and constant B. That's from the table. If you go back, you can find those from the table. Usually B is 1.75, and this is going to be 0.28 or something from the back, and the GPM we got already from there. So you get those numbers, and we're going to use this formula now. So friction losses and pump fitting, this is the same thing, and we will plug in this number in here, the total number of length, and A will go in here, GPM will go in here, and the B will be in here as is. You crunch those numbers, and it will transfer to the bottom in here. After you get the calculation, you multiply them all together, and you'll get your feet of head loss based on the friction losses and fitting losses. So having that, you will add to that number, which is now number 3 here, you transfer it to here, what is the total static head, which is the height of the building. As we said, if we have 3 stories, you're going to calculate the height from the top to the bottom. That's going to be your height, and this will go into here. Okay, we got that. We add those two numbers together, here and here, and that is your pump head. So we get the head and the GPM, and this form hopefully will make things a little bit easier if you follow the steps and fill in the blanks as you go along. Okay, now we're moving on into thermal expansion tank. The thermal expansion tank usually placed before the pump outside of the boiler, and the purpose of this tank is to pressurize the water and also to take all the expansion of the water when it's heated. When we heat water, it does expand, and this is the amount of expansion we will have in that system. So it makes things, the water that we have is all the water in the system. So thinking about that, what is the water in the system? You have water in the pipe, right? Pipes plus boiler. Unless you have on-demand boiler, it's going to have some water. and also in the radiator. So these are the sum of all the water inside the system, because we need to know how much it will expand. Okay, what are the calculations done to calculate this water? Let's look at this. Even though it looks very hairy and kind of complicated, it is not. If you dissect that into small little pieces, first we need to calculate something called the P fill or P charge, which is the pressure as filled and the pressure as charged as is when it's cold. If you think of those components, HS is the height of the system, H tank is the height of the tank, that's the height of the system. This is the, I will explain the next slide. D cold is the density of the water when it's cold. 144 is a conversion. We have two types of tank, air cushion expansion tank and diaphragm expansion tank. This one we're not going to use for this project, we'll use only this one. But at least you know that you have this formula. And PRV and P charge is what you calculated from here. PRV again is the same as this one, and usually it's 30 psi. And D cold, density of the water when it's cold, density of the water when it's hot, and the volume of the system. The volume of the system is the volume of the water in the system. Volume of the water in the system. Okay, how do we go about calculating that? Again, there's a form for that. You can fill the form and follow the terminology. So this is a picture of the entire system, and we're thinking of all the water in these components, pipes, all this amount of water has to be calculated in the volume. So we have to account for all of them. So again, these are the nomenclature for all the stuff we have in this formula. So the PSI for the relief valve is 30, volume of the tank, minimum size of the tank, B the system, D is the density for the water, hot and cold, P fill or P charge, PRV, height of the system, and height of the boiler room. So if you follow these things, it should make sense. We go with the math. Again, usually we use PEMDAS, which is parentheses first, exponents, multiply, divide, addition, subtract. Let's say you're not very familiar with that, you can use the form again to fill in those. And there's also a calculator that I put in Blackboard that will help you. Just plug in the numbers and we'll do the math for you. So this is the calculator, it's in Blackboard, and the references. You will insert these values, and these values actually are available in the last page, the formula page in your book. This is always 30, unless otherwise has been noted. Height of the system is the highest point of the system from the bottom to the top. Height of the tank usually around 6 feet. Usually those tanks are hanging on the top, and the volume system, which we have to calculate. So you plug in those numbers and it will give you the size of the tank that you need. So try to manipulate that or work with it and see how does it work for you. This is the water density. This is also in the back of the book, and if you notice, we are talking about the density of the water at certain temperature. So if I say the temperature of the water when it's cold is 60, don't put 60, you're going to put 62.37, because we're asking for the density, not the temperature. So when you go to that formula, it's asking for the density, and this is where you get the density. D is for density. How do we calculate the system volume, or the volume of the water in the system? So we have the volume of the pipe, volume of the boiler, volume of the radiator. So we are thinking of the volume of the water in the pipe. If we think of, this is the pipe, a piece of pipe. So the volume of the water is going to be the area here of the pipe, which is pi r square, r being the radius, pi is 3.14, times the length of the pipe, which is this part here. So that will give you the volume of a cylinder. So thinking of that, we can calculate and estimate the volume of the water inside the pipe. That's for the pipe. For the the boiler, there's another formula that I will show you now. And the radiators, if you are using baseboard, probably it's 3/4, so it can be considered as same as the pipe. This is volume in the pipe. So if you have, so things are really tabulated and very easy for you. So you're just following the process, knowing to look for things. So volume of a pipe, that's 3/4 of an inch. If it's copper, it's going to be this much per foot. If it's steel, it's going to be this much per foot. So we're going to take the total, we're going to find the total length of the pipe and multiply that by the gallons of water. That's are the components that you're going to use for your system volume sheet. This is basically the system control you will need to put in your system, and we have covered this in the combustion controls form. Okay. What else? So another example here for you to practice, and I want you to see if you get the right